Imagine our night sky, a familiar canvas dotted with stars, dominated by one steadfast companion, the moon. It's a constant, a gentle light, a subtle tug on our oceans. But what if that familiar canvas suddenly hosted two such celestial neighbors? Our imagination often leaps to immediate, superficial changes, brighter nights, perhaps, tides that are a little higher, a little lower, maybe just twice the romantic glow for evening strolls, but that's thinking too small. If Earth had two moons, the first thing to change would not be the obvious one. It would be the fundamental survival constraint. The very rules of existence would rewrite themselves. What hidden forces would two moons unleash upon our blue marble? And how drastically would life itself have to adapt or perish? Our single moon is a relic of cosmic violence. Scientists believe it formed when a Mars-sized object, named Theia, slammed into early Earth. The debris from this titanic collision coalesced, eventually becoming our familiar satellite. What if, instead of one, Earth had captured a second, smaller celestial body? Or perhaps two such impacts happened. This isn't just about adding another rock to the sky. It's about an entirely new gravitational dance. The number, size, and orbital path of celestial bodies dictate everything. Our current moon orbits at a stable distance, its path predictable. A second moon would introduce an entirely new set of gravitational interactions. Would it be smaller, larger, closer? Its characteristics would define the chaos. The very premise of two moons existing stably around Earth is fraught with peril. Celestial mechanics, the intricate ballet of gravity and motion, dictates that such a configuration would be inherently unstable. Our current moon occupies a gravitational sweet spot, a stable orbit achieved over eons. Introducing a second, similarly sized, or even smaller body into Earth's immediate gravitational sphere would immediately trigger a complex, potentially destructive interaction. They would tug at each other, pulling and pushing, constantly altering their paths in a cosmic game of billiards. This gravitational interference could lead to orbital resonance, where their periods of revolution align in repeating, destabilizing patterns. Imagine one moon completing two orbits for every one of the other, or 3 for 2. Such resonances, while sometimes leading to temporary stability in other systems like Jupiter's Galilean moons, are more often precursors to chaos, especially with two large bodies around a primary. The outcomes of this gravitational instability are grim and varied. One scenario sees one moon being accelerated by the gravitational slingshot effect of the other, gaining enough velocity to escape Earth's gravity entirely, flung out into the cold vacuum of space, lost forever. A more terrifying possibility involves the inverse, one moon being slowed down, its orbit decaying, dragging it closer and closer to Earth. This slow, inevitable descent would be horrifying to witness, a growing threat in the sky. Eventually, it would cross the Roche limit, the critical distance at which a celestial body's own gravitational cohesion can no longer withstand the immense tidal forces exerted by a larger body like Earth. At this point, the moon would be torn apart, not in a single cataclysmic explosion, but in a gradual, mesmerizing disintegration. Its shattered remnants would spread out, forming a temporary, spectacular ring system around Earth, much like those of Saturn. This celestial jewelry, however, would be short-lived, as the fragments would either eventually collide with Earth, be swept away by solar wind, or reaccrete into smaller, irregular moonlets. The fate of the two-moon system, in most realistic orbital simulations, is almost certainly violent and transient. But let's assume, for the sake of our thought experiment, a brief, precarious stability, just long enough for us to explore the consequences before one or both moons meet their ultimate fate. The most immediate and profound impact, once those orbital mechanics momentarily settled, would be on our oceans. Tidal forces, the stretching and squeezing effect of gravity across a planet, are currently dominated by our single moon and, to a lesser extent, the Sun. With two moons, especially if they are of significant size and orbiting at different inclinations or distances, these forces would amplify, sometimes constructively, sometimes destructively, creating a tidal nightmare. Imagine tides not measured in feet, but in stories, perhaps reaching hundreds of feet in height. Instead of the gentle ebb and flow we know, twice a day the shoreline would recede not just hundreds of yards, but miles, exposing vast, muddy, or barren seabeds, only to rush back with unimaginable speed and devastating power. Coastal cities, if they could even be conceived of, would be regularly swallowed and uncovered by a furious, churning ocean. This wouldn't be just a bigger wave. It would be a fundamental reshaping of the land itself, with constant, brutal erosion and deposition. Life in the intertidal zone, adapted to specific ranges, would be utterly obliterated. Marine currents would become colossal, unnavigable torrents, transforming ocean ecosystems into chaotic, violent environments. Beyond the oceans, these magnified tidal forces would also tug at Earth's solid crust, a phenomenon known as solid Earth tides. Our planet isn't a perfectly rigid sphere. It's a slightly squishy ball, with a liquid core and a semi-molten mantle beneath a solid crust, constantly flexing. The current solid Earth tides cause the surface to rise and fall by mere centimeters. With two moons, especially if they were to frequently align, this flexing would increase dramatically, potentially by meters or tens of meters. This constant internal friction, akin to continuously bending a metal wire, would generate immense heat within Earth's interior. Volcanoes, already active, would erupt with far greater frequency and intensity, spewing ash and lava across vast regions, darkening skies, and poisoning atmospheres. Supervolcano eruptions, currently rare, might become a regular occurrence, altering global climate patterns with each blast. Earthquakes would become a daily, even hourly occurrence, not just minor tremors, but major destructive quakes, as the planet's tectonic plates groaned and shifted under the ensue. Relentless gravitational stress. Building stable structures would be an impossible dream. Any attempt at permanent human habitation on the surface would be shattered in short order. Could any complex life truly thrive under such constant, planet-wide geological upheaval, or would existence be a relentless struggle against a perpetually fracturing world? The Earth's rotation would also feel the dramatic effects of this double lunar embrace. Our single moon already acts as a cosmic brake, slowing Earth's spin by fractions of a second per century, gradually lengthening our days. Two moons, especially if they were massive or had complex, resonant orbital dynamics, would accelerate this process dramatically and unpredictably. Days could become shorter as one moon's gravity speeds up the Earth's rotation, then significantly longer as another moon's pull, or a different alignment, acts to slow it down. Imagine a 10-hour day followed by a 30-hour day, all within a few years or even months, with these fluctuations being nonlinear and chaotic. This would wreak havoc on any biological rhythms that evolved under a stable, predictable solar clock. Photosynthesis cycles, crucial for plant growth, would be thrown into disarray. Animal sleep patterns, migration instincts, and reproductive cycles, all keyed to the length of day and night, would become meaningless. Even the fundamental chemistry of life, based on metabolic rates and environmental cues, would be thrown into disarray. What species, let alone an entire biosphere, could adapt to such temporal chaos, where the very concept of a day was a moving, unpredictable target? Furthermore, our moon plays a critical role in stabilizing Earth's axial tilt, the 23.5-degree angle that gives us our seasons. Without this stabilizing influence, or with the conflicting poles of two moons, Earth's axial tilt could wobble wildly, undergoing drastic shifts over relatively short periods. Imagine the poles sometimes pointing directly at the sun, then swinging to point away, creating extreme, unpredictable climate swings. One year might see perpetual summer in the northern hemisphere, followed by a period of extreme cold, then perhaps a time when the equator experiences near perpetual darkness. These chaotic shifts would render any long-term climate pattern impossible, preventing the formation of stable ice caps or consistent rainfall. Coupled with the atmospheric effects, the climate would be a chaotic dance of extremes. Rapid shifts in temperature, intense precipitation followed by searing droughts, would become the norm. These conditions would make agriculture, as we understand it, utterly impossible, eroding away topsoil and washing away crops in an instant. Could any organized civilization survive, let alone flourish, in a world where the very air was a weapon and the seasons themselves were a cruel, unpredictable joke? Our atmospheric pressure would also fluctuate wildly, creating another layer of environmental terror. The gravitational pull of two moons would generate immense atmospheric tides, much like oceanic tides, but in the air itself. Air pressure would rise and fall dramatically and rapidly, creating massive pressure gradients across the globe. This would generate super hurricanes and colossal storms far beyond anything we experience today, perhaps with winds reaching speeds of Mach 1 or more, capable of stripping the very atmosphere from the surface. Winds would howl across the land, tearing at anything not bolted down, or rather, rooted incredibly deeply. The climate would be a chaotic dance of extremes, rapid shifts in temperature, intense precipitation followed by searing droughts. These conditions would make agriculture, as we understand it, utterly impossible. Could any organized civilization survive, let alone flourish, in a world where the very air was a weapon? The constant buffeting and erosion would reshape continents, grind down mountains, and fill valleys with debris, leaving a barren, windswept landscape. Furthermore, the night sky itself, while brighter, would be a source of constant dread and disorientation. The combined light of two moons, especially if they were both full or near full, would eliminate true darkness, creating a perpetual twilight. But this wouldn't be a peaceful glow. It would be an ever-shifting, unpredictable illumination. One moon might frequently eclipse the other, or both might align, casting strange, dancing shadows that constantly changed in intensity and direction. The frequency and complexity of eclipses would increase dramatically, sometimes plunging the world into a brief, unsettling darkness, only for it to be instantly replaced by the piercing light of the other moon. This continuous twilight would confuse nocturnal predators and prey alike, disrupting hunting patterns and forcing new evolutionary strategies for vision and camouflage. The lack of true dark cycles would also impact plant growth, which often relies on a precise balance of light and dark for photoperiodism, influencing flowering and dormancy. Imagine the psychological toll on any sentient beings living under such an erratic, foreboding celestial display, where the familiar comfort of night or the clarity of day is replaced by an unending, unsettling spectacle. How would humanity perceive time or build narratives around a sky in constant, unpredictable flux, where the heavens themselves were a source of anxiety rather than inspiration? Life, if it managed to survive at all, would be profoundly different from anything we recognize. Early single-celled organisms might persist in deep, insulated ocean trenches, far from the surface chaos, or within the Earth's crust, shielded from the ceaseless geological and atmospheric violence. But multicellular life, especially complex land animals, would face immense challenges. Plants would need incredibly strong root systems, capable of anchoring themselves against constant geological shifts and titanic storms, or perhaps they would evolve to be extremely small and fast-growing, opportunistic survivors in transient calm periods. Animals would require adaptations for incredible physical resilience, perhaps developing internal systems to cope with constant gravitational fluctuations, or the ability to migrate rapidly across a constantly changing, fragmented landscape to find fleeting pockets of stability. Evolutionary pressures would favor the incredibly robust, the incredibly adaptable, or the incredibly quick to reproduce and disperse. The slow, gradual, stable evolution we know would be replaced by an urgent, brutal selection process, driving rapid, desperate adaptation or swift extinction. Would sapience, the development of complex intelligence and culture, even be possible in such a world, where the very act of survival consumed all resources and attention? Could beings develop the stability and leisure required for abstract thought and complex social structures if their entire existence was a desperate scramble for momentary reprieve? Consider the implications for something as fundamental as gravity itself. While the overall gravitational pull of Earth wouldn't change drastically, the asterisk, local asterisk, and asterisk temporal asterisk variations would be enormous. Standing on the shore during a super high tide, you might feel slightly lighter as the combined lunar pull lifts the water and you away from Earth's center. Hours later, as the moon's shift, you might feel subtly heavier. This constant, subtle alteration of gravity would impact balance, growth, and even internal biological processes. Plant roots, which grow downwards in response to gravity, geotropism, would be constantly confused. Animal skeletons and musculature, designed for a consistent gravitational field, would face unprecedented stress. Perhaps creatures would evolve flatter, wider bodies to resist the constant buffeting of winds and water, or powerful suction cups to cling to the ever-shifting ground. Some hypotheses even suggest that a constantly flexing planet with increased internal heat could affect the geodynamo, the process that generates Earth's protective magnetic field. A weakened or chaotic magnetic field would expose any surface life to increased solar and cosmic radiation, adding yet another layer of existential threat. The very notion of stability would cease to exist. Life would be a perpetual act of dynamic adaptation to an environment in constant flux. So, this thought experiment isn't just about adding an extra sparkle to the night sky. It's about unraveling the intricate web of forces that make Earth habitable and life possible. Our single moon provides a stable, predictable influence. It regulates our tides, creates stable intertidal zones, and acts as a crucial stabilizer for Earth's axial tilt, preventing wild climatic swings that would sterilize the planet. It slows Earth's rotation at a manageable pace, allowing for the evolution of circadian rhythms. It even acts as a gravitational shield, deflecting some incoming asteroids and comets. It's a silent, constant partner that has allowed life to flourish over billions of years, providing the predictability and stability required for complex ecosystems and, ultimately, civilization to arise. Without its consistent presence, or with the chaos of a second rival moon, our planet would be an entirely different, far more hostile, and almost certainly uninhabitable place for any life beyond the most resilient extremophiles. This counterfactual journey highlights the delicate balance of our cosmic home, revealing just how narrowly tailored our existence truly is. We often take for granted the stability of our environment, the rhythms of day and night, the consistency of our tides, the gentle turning of the seasons. But these are not universal constants. They are the carefully orchestrated, finely tuned results of specific gravitational interactions, a precise cosmic dance involving Earth, the Sun, and our singular, steady moon. A slight alteration, a single extra celestial body introduced into this delicate system, could cascade into a maelstrom of destruction and perpetual, unbearable change, transforming a cradle of life into a turbulent, violent wasteland. Our reality isn't just a happy accident. It's a precisely tuned system, a testament to cosmic serendipity. The presence of our lone moon, steady and serene, isn't merely a pretty backdrop for romantic dreams. It is a fundamental survival constraint, a prerequisite for the very existence of complex life as we know it, a silent guardian allowing us to exist. So, as we gaze upon our singular, steadfast moon, perhaps we should see not just a familiar companion, but a silent testament to the extraordinary, often invisible constraints that permit our very existence. What fundamental forces, what subtle rhythms, what quiet guardians are shaping your reality right now, and what seemingly insignificant alteration could unravel the intricate tapestry of life.